So as the alcohol trickles back down, it leaves behind on the bubble plate that's situated behind every one of these windows, and you can see them in the small column as well. It leaves behind a thin layer of liquid, about 10 millimetres thick. And again, if you look through the windows, you can see that above each bubble plate there's a bell made out of copper. Everything that the spirit touches is made out of copper. And the lip of that bell extends just into the layer of liquid. So any vapour that comes up subsequently is forced by the underside of that bell to pass into the layer of liquid. And because you've got a vapour going into the liquid, it will condense. But energy can't be created or destroyed. That's a fundamental law of physics. So something will also have to give, something evaporates. And because alcohol has got a lower boiling point than water, it will always be the alcohol in this mixture that evaporates preferentially, turns back into a vapour and moves up to the next level where the whole process is repeated again. Does that make sense? So from that, hopefully you can see, as the vapour moves up the column, it gets progressively purer and purer and purer. And on this bottom plate, that can be a big step change from about 40% ABV up to 65% ABV. But it gets harder and harder to do. So right up the top of this column is going from, say, 96.2 to 96.23%. So very small changes at the end. So that's why the height of the column is so important, and the size of the column is critical in making vodka. So that's how we use this to increase the concentration of alcohol. But what we also want to do is improve the quality of it. Up until now I've been talking about alcohol as though it's just one substance, but of course it's not. We've got methanol, ethanol, propanol, butanol. We've also got all sorts of other substances that are formed in fermentation, aldehydes and ketones. And really, when we're making vodka, all we want is the ethanol. And the way we separate out all these other substances is by relying on the fact that they've all got different boiling points. So when we first set this running in the morning, we leave it to circulate with a lot of cold water at the top of the rectification column. So that means that all the alcohol can get up to the top, but it can't escape. And then we just leave it circulating for 2 hours. The effect of that is to concentrate the substance with the lowest boiling point at the top of the column, because it's always the lowest boiling point substances that are going to come off preferentially. Yeah? And that lowest boiling point substance is methanol. I think methanol boils at about 64 degrees centigrade, something like that. So we run it for 2 hours. The methanol all gets trapped right at the top of the column. We then reduce the amount of cooling water. About 10 minutes later, the alcohol vapour is able to escape. It comes down here into this condenser that turns it back into a liquid, and the alcohol then flows out over this spout here. But the first bit that comes off is very rich in the methanol. And we take a little sample here and sniff it, and it's got a very chemical smell. It's not unpleasant. It's always described as smelling like nail varnish remover, but that is the methanol. And we need to take it out because it is strongly flavoured and it makes you go blind, so that's not a good idea to keep it in.